right. Hello, everyone. Welcome to an introduction to programming in Python. This is the first of our series of DSCoV workshops, and DSCoV stands for Data Science, Computation, and Visualization workshops. These are 1-hour skill-based workshops that are held throughout the fall and spring semesters, and they're going to be on Fridays at this time. So come back, look at the calendar, see what's up next. But today we're doing an introduction to programming in Python. And before I got started, I kind of wanted to know a little bit about how much experience people had in programming. So who has never programmed before or is like not, or like would consider themselves very beginner? 2, 3. Okay. Zoom folks, super beginners. Cool. We got a hand. Yes. Great. So that's a handful. How many of you have learned Python before? Okay, we got another set of handful in the room. And folks on Zoom, feel free to put in the chat. How many of you have never done Python before, but have done a different programming language? Okay, okay. Much smaller handful. Well, today we're going to go from the very beginning, it looks like. I think that's kind of where we're going to go, since we have a handful of folks that haven't programmed before, and this is going to be the very start of a journey. And while we get started, if folks could scan this QR code or go to this URL, I'll put this URL in chat for those on Zoom. This is just attendance for us. This is an opportunity for you to just say that you attended today. And I actually don't know if this is a response or this is at the beginning. You might want to do this at the end, depending if this is a feedback form. I should check. Let me see, what is it? It's just attendance, right? Okay, great. It's just attendance. Feel free to suggest other DSCoVs and things like that. Great. So let's get started. So this is the quote from Python's official website. Python is powerful and fast. It plays well with others, runs everywhere, is friendly and easy to learn, and it's open. So Python is a very common programming language that is used pretty much everywhere. And for me, this was kind of the first programming language that I learned, and it kind of forced me into some really nice habits. A little bit more about Python. It's an interpreted scripting language, which kind of basically means, and it's a high-level programming language, which basically kind of means that like you're going to be able to, you're like not flipping bits. Like it's not so like abstract that you have to, it's not that you have to like do zeros and ones. You're going to be able to do things that are a little bit more legible, I want to say. It can be an object-oriented program. So what I think about object-oriented programming, I kind of think about Pokemon. So I kind of think about each Pokemon as an object, I know. But like they all have attributes. So like Pikachu is electric, right? But it also has actions. It has things like tackle or like Thunderbolt or things like that. So that's what I kind of think about when I think about object-oriented programming. Though I think now a lot more programming is a lot more functional, and we can talk about that later. It's dynamically typed. So if you're familiar with other programming languages that force you to say like, this is a number, and then like then you can actually set it to a number. Python will do it for you. Python will be like, okay, what is you set a variable. I believe that's a number. Great. Another really nice thing about Python is that it's garbage collected, which means we don't really need to care about allocating memory or deallocating memory. That if you get into a low-level programming language like C, C++, you'll have to manage things there. But Python will do it all for you. Here are some reasons why learning Python is good. It's easy to learn. It's pretty readable as a language. The styling of Python really makes it so that you write really short things and kind of keep your code pretty tidy. There's a huge community behind Python, so you'll find hundreds of libraries and frameworks. So what we're going to work on today is kind of like the base Python, but if you go into other sorts of disciplines where you're like, maybe you're doing geospatial analysis, there's probably a library for that. And that's something where you're going to be able to pull attributes or methods from. And we'll talk about what that is. There's a combination here in Python of versatility, efficiency, reliability, and speed. For me, I kind of consider Python a little bit of more of a jack of all trades, or like the second best language for what you want to do. Because if you want to do certain things, there's likely like a more bespoke or specific programming language that might do it better. But realistically, like, I think Python's a really good one to start with because it's pretty easy to share it with people. And you'll find that sharing code and getting people to review your code is honestly, to me, more valuable. It's used a lot in data science and analytics. You'll see packages or libraries such as pandas or NumPy. They're pretty popular. We're not doing that today since this is intro. Automation, as with all programming, it's automation. There's a large user base and community, and it's open source, which means it's not, proprietary. If you ever used MATLAB is proprietary, and I believe like Brown has a license for it. But if you're not at Brown, if you're not a student, if you work at a company or something like that, and they don't have MATLAB, getting a license for MATLAB costs money. Python is, however, free and open source. Yeah. So that's kind of my spiel about why learn Python. Let's get into our environment setup. Today is going to be pretty easy. We're actually just going to do it all in the browser. So we're going to go to trinket.io trinket.io/Python3, and I'll put that in chat here. So, whoa, I made that really big. Yes, you can follow along using Google Colab if you would like. Expand. Okay. I'm using trinket.io/Python3 today just because I don't need to install anything. And so I click the expand so that I can kind of have two sides. So this left side is our main.py file. So all Python files are .py files. And then on the right over here is going to be our output. So this is just how our setup's going to be. We're only going to have one file and things like that. If you were to run this locally on your computer, you can use things like your own development environment, such as VS Code. I think that there's also like IntelliJ, PyCharm, I think is a really popular one also. Sorry, someone in Zoom, you have your I'm just gonna mute everyone. Great, cool. Thank you. Great. So now let's head off to our first program. So the first thing that you'll do in every programming class is hello world, or printing out hello world into the console. This is typically the first program you'll write because this is basically checking to see if your environment is set up correctly. I do this every time I set up a project. It's not necessarily the same thing every time, but usually it's either like printing this out, or if I'm doing like a web app, I'm just trying to load it and make sure that it opens for the very first time. This way I know my environment works, and then I can start coding. So our first program is going to print. So there's these first letters, print, and then inside we're going to be doing these parentheses. Note that it autofilled the ending parentheses for me. Sorry. That's very important. You always want to have your ending. And you'll also make sure you want to match them all. So whatever quotation marks you have or parentheses you want to make sure you have the opening and the closure. If I press this run button over here, you'll see that in my console, which is right here, we've printed out the words hello world. Great, our environment has been set up. Now, before we even get to any sort of programming, I want to talk to you a little bit about the program design cycle. This is before I do any code, right? Because the first thing that I do before code is not write code. I need to figure out what I'm trying to do. And honestly, this is a lot more relevant now, especially with folks using AI as well. Really thinking about what my project is. So I need to define what sort of task I'm about to make. I need to analyze kind of what that task is, what kind of algorithms I need before I start coding, right? And then after I do some coding, I document my code, I'll test and debug it, and then I'll maintain it. And then I'm kind of in this cycle. What that looks like in reality is kind of like this. I kind of do best practices, but honestly, like, it's an iterative process and I try my best is what happens. But let's start with some good practices. We're going to comment our code. In Python, how we comment our code is using this pound symbol or the hashtag symbol. So if we go here to our Python code and we say, this is a comment, you'll see that it is highlighted in green. This is a comment, and if I press run, it will just say hello world. If it wasn't a comment, if I press run, I get an error. And this error message tells me I have an error on line 1. It also notes where it is, and it's telling me I have invalid syntax. So programming is a very syntactical language where if the compiler is not going to be able to read it, you're going to get an error message. And oftentimes it's helpful, but sometimes you might run into things that the program might not be able to tell you is wrong, and you'll have to logically figure it out. If you wanted to comment multiple lines, I usually do command / while highlighting everything, and that should comment everything out. Okay. By the end of today, we're going to be programming a little game. So in order to get there, we have to get through some basics. So we're going to talk about some basic data types. So there are things like numbers, which in Python are integers or floats. Integers are, as you see here, are numbers like -1, 0, 1, or 2. We have floats that are basically decimal numbers, and that could be things like 3.14, 0.1, 7.8. We have strings, which are essentially just words, just text. Strings are noted with these quotation marks. If you put a number in quotation marks, that will be a string. That is a string. That is not a number, and you won't be able to use it as a number. We have Boolean, which are true or false values. There's only two values there. And then we have null, which is basically a none type, which is basically if you ever have things like missing data in your tables or things like that, that's like what it would be. We're not going to be dealing with null today. Or we might. We'll see. So those are some of the data types. And now we're going to need to save it into a variable. And variables are names for data that it's assigned to. So for example, like for number of days in the week, like we could say like days of the week equals 7, something like that. Each variable has a data type. As I discussed earlier, Python is a loosely weakly typed programming language, so you're not going to have to define the type. It's going to interpret the type for you. For our variable names, however, what we're going to have to do is they're not allowed to have spaces in them. So I wanted to say days of the week, right? Days of the week equals 7. That's not allowed because there's spaces between the words. So for variables, no spaces are allowed. You're allowed to start with a letter or an underscore. You can't start with a number. It's case sensitive. So if you spell it differently with different casing, they're going to be considered different variables. There are some reserved words in Python that you're not allowed to use as a variable name. And those are things like import. If you wanted to grab a library, you're not allowed to use import as a variable name. In Python, there's a lot of conventions. So one of the conventions is snake case. So in Python, we have snake case for variables, and we have screaming snake case for constants that are global. Today, we're just doing snake case, and that just means every space is replaced with a underscore. So to make our program not yell at us anymore, days of the week, run. I mean, it doesn't print anything because we didn't print anything. But if I printed like the variable, you'll see 7. So now that I saved 7 into this variable days of the week, I'm allowed to use it later in my code. So this is another design principle in Python. You want to define things once and then use them all over the place. Because in my program, I could be using 7 all over the place, but that could be a pain if that ever changed. Like, what if there were 8 days of the week? I don't know. But what you'll find is that like Python has a style guide. So this is the Python style guide, which tries to tell you how to lay out your code. In Python, spaces for indentations are part of the syntax, and we're going to be doing that today as well. Feel free to read more about the style for Python code. This will make your code cleaner, and it will also kind of put you into a good coding style. So as I was talking about before with our numbers, our ints and floats, with those, we're allowed to do math with them. So we're allowed to do things like add, subtract, multiply, or divide, or some floor division. So let's go back to this. I could do things like 7 plus 5. And if I run that, I'll get 12. Let's do 7 times 5, 35 minus things like that. I don't have to save these numbers into a variable. I can just use them as numbers. But if I did want to use the variables, I can grab those. Some other ones are things like exponent or modulus. So if I wanted to do like print like 2 to the 3rd, that would be 8. If I wanted to do 5 mod 3, should be 2. Things like that. If I tried to do anything with this with a string, so if I like try to do 5 divided by 3 in a string, it would just print out the string. Cool. So we got some basic data types. I think the last thing that, not the last thing, but like the last thing before I introduce our game is we want to get an input from the user. So we've already talked about print, which prints out whatever text or anything that I put into those parentheses. But input is a function that will pause our program and prompt the user for to type something. So if I say something like input, what's your name? And if I run that, you'll see that I have a little cursor here that's like blinking. I'll say Ellen. That's the end of my program. It didn't print that back out, but if I wanted to print out what I wrote, I could encase all of that in a print. I could save that into a variable called name, and then I can print out a response. Oh, shoot. Is that in the next, that might be in the next slide. It's not in the next slide. Great. I could do something like this, where I believe like this. Sorry, let me check this out. Does this work? This might not be it. Oh, I don't need the $sign. Sorry, I've been coding in JavaScript for too long. Okay. So in this first line, I've asked the user what their name is. And then in this next line, I'm actually printing out a little bit of a response. I'm actually using what was passed and saved into the variable name, which was Ellen. So now I'm printing it using a F string, which is a formatted string in Python. So I just put an F before my quotation marks, and then I can use variables inside of that string. So now I've asked the user, what's your name? And the program responds back, hello. And then my name, hello, Elliot. Great. Something to note is that for everything that we get back from input, it will always save it as a string. So this name variable is a string. If we wanted a number from the user, if we wanted a number from the user, give me a number. Right now, if I print this out, it prints out 4 just fine. The problem is, if we try to figure out what the type of that number is, so let's try it again. It tells me that it's of type string. That's a problem for us if we want to get numbers from a user. So in order to kind of get around this, so I used type around my variable just to see what it was. I can cast it. So casting is where you might want to specify the type of a variable. Usually on your data import, like if I'm importing a huge like Excel file or CSV or something like that, I'll need to go back and say like, hey, this was a column of numbers, or like this was a date or something like that. So this is kind of a similar concept to that. So in this case, we are going to get an input and cast it into an int. We're just going to deal with integers today. We're not dealing with floats today. We're going to run that. So here's 4, and now it's an int, which is great. If I tried to put in a string, it's going to say error. You cannot cast a string that's Ellen into an int because it doesn't work that way. We're not going to deal with this error today. We're just going to mosey along. But that's how we'll get input from our users. All right, so let's introduce the game that we are going to do today. We're going to do a guess the number exercise where we're going to get the user to guess a number. Maybe it's between 1 and 100. And we're going to tell the user whether or not they guessed it correctly, or if they need to guess lower, or if they need to guess higher. If they guessed it wrong, we're going to prompt the user again for another guess and let them try again 3 times. So far, what we have right now, we don't have enough to actually do this. The other missing piece is that we're going to need to better understand our Booleans. So I know strings and integers and numbers, we got. Booleans are going to be how we're going to do those relational operators, where we're going to be able to tell a user, oh, your number is too low, or your number is, or you need to guess higher, something like that. So these are the data type that evaluates either true or false. Here are our list of relational operators. We have equals to. So if I go back to my Python code here and I say print does 5 equals 5, it will print out true. If I say is equal to 6, it'll print out false. So this tests equality, but sometimes we want to test inequality, and that will be this exclamation point equals. So this is saying 5 does not equal 6, and that's true. Note that we used 2 equal signs to test equality, because if you use just 1, that's trying to set it equal to this thing. So remember, we used 1 equal sign for variable assignment. We're using 2 for testing equality. We have other things such as greater than, less than. So is 5 greater than 6? No. Is 5 less than 6? Yes. We also have things like greater than or equal to, which is just the greater than sign and then the equal sign. And then we have less than or equal to. And those are just a combination of those two. Great. Do I want to go through that? I don't think I do. Okay. We're going to pass by truth tables. And we're going to go into our if statements. This is once we get back from our user, like what number that they're guessing, we can check if it's greater than or equal to something. But in order to do that, we're going to need to use these if statements. So these are conditional statements. And they're going to evaluate whether something is true or false. So for example, in English, if it rains, we'll watch a movie. If it's sunny, then we'll go outside for a little hike, something like that. So it's basically saying, if this condition is true, then we're going to do this second action. And this is kind of how you would control the flow of your program. So you're going to do things like this. So you're going to check whether your condition is true or false. And if it's true, you can do something. If it's false, you can do something else and then continue with your program. So in context for Python, the syntax would be if, and we'll say 5 equals 5. I think I might need to put that in. Actually, I don't think I need to. Print equals. Notice that it indented me in automatically. So I use this if. I have my condition. I have this colon, meaning this colon, and then the action is indented in. So basically in Python, everything that's indented in like one level is inside of this if statement. In other programming languages, you'll see a little bit more explicitly, you'll see like quotation, not quotation marks, you'll see curly brackets. But in Python, just an indentation will work. Okay. What if 5, does 5 equal 6? No, as you can see, it skipped that and went straight to the end of the program. Maybe we want to do something if it's false. In that case, we can use an else statement, which just tags along after our if statement. We're going to dedent. It's not what it's called. I think it's called. So you say else, and then you have a colon here. And then you can print not equals. So we'll run that. Notice that the else is in line with this if, and then we have a print here. And so as you can see, we're printing not equals and end of program. So this is how you'll branch in your code. A fun thing will be if you wanted to do an else if statement. So this is like how you would execute your code if you wanted to have more if statements, basically. I think I have an example for this or not. All right, great. Unfortunately for me, equals is always one or the other. So I'm gonna just make a variable pies equals, not pies, pizza slices. I'm gonna say pizza equals 3. If pizza equals 6, I'm gonna say yay. Yay. So else if, I can say else, and then I can say if, but I need a condition. So my condition is if pizza equals 3, print pizza. So the else if gives me an opportunity to ask another condition. And then it'll do another condition. And yep, my bad. I know, sorry. I've been coding in JavaScript a lot. Anyway, so the shorthand for else if is elif, E-L-I-F. And now you can see it first checked if pizza equals 6, which is false. So it went to the next condition, which is else if pizza equals 3. And pizza does equal 3. And so it printed out pizza. And then it escaped and did not print out the rest. And we're at the end of program here. You can do something a little crazy. If you wanted to nest if statements, you can have if statements inside of if statements. I don't think we need to do that today. Because basically you can say if this first condition is true, then we're going to go inside. You see this indentation. If this second condition is true, then we're going to do the action in both conditions. Sorry, in here. But I think we have enough to do this exercise now. And we're going to do it together just because of time. But first things first, we're going to kind of talk it through the things that we need. We need to set a secret number for a user to guess and to compare to. We need to get a number from a user. And then we need to compare that number to a user, compare that number. And then we're going to need to allow the user to guess multiple times. 3 times, I think. So that's the first thing I do before I code, actually, is kind of write down a little schema of like, what do I want to do? And I did that all with some comments here. So let's call our secret number. We're going to call that, I don't know, 47 sounds good. We're going to get a number from the user. So the way that we did that is that we used input. We're going to say, guess a number between 1 to 100. Remember, we're going to need to cast it. But before I get too crazy, let's just print out the guess. Another thing I like doing is I like testing early on. So I don't want to like write this whole program, find out it breaks, and then figure that out. So guess the number between 1 and 100. I don't know, I'm going to say 40. I printed out 40. I kind of want to have a colon here just to have some better. That feels like a better prompting to me. Great. Cool. So now that I have that number, I want to guess, compare that number if the guess is less than my number, then I want to say higher to get the user to guess higher. If the guess is higher than 40, then so look at me, I used 47. I could have used our secret number variable, so I don't have to type 47 everywhere in my code. So if the guess was higher than the secret number, I want to say lower. And otherwise, I'm gonna say correct. All right, great. So we're just comparing that number against one try, right? We're not even doing this last bit of allowing the user to guess 3 times. So let's guess a number between 1 and 100. We're gonna say 40. And now it says higher. If I guessed 50, it says lower. If I guessed 47, it says correct. That's great. Now the question is, how am I going to do this thing where I allow the user to guess up to 3 times? Based on what we know right now, it seems like I can do like a nested little for loop. Sorry, a nested if statement. My bad. I'm getting ahead of myself. So we're gonna need to do a couple of things. If the if the guess was too low, we have to let the user guess again. So we have to say guess again. And then we want to compare that again. So now we can kind of see that our code is getting a little bad. But, you know, this is how it be. Sometimes, you know, we're letting the user guess again. So this is our second guess. But it looks like we might have to do that again for this other one. Right? I think we'll just do 2 guesses right now. I think that's fine, just based on what we have time-wise. Ooh, I have an unexpected indent somewhere. Line 19. Aha. Found. So if I guessed low on the first guess and I'm getting the user to guess again, and then I'm doing the whole same compare higher, lower, correct sort of thing. I'm guessing 40. So it's too low, higher. So if I say 78, it says lower. Great. Cool. Oh, but the original prompt asked, actually, we do have time. We'll do 3 times. So let's see. Now I have to do something like guess 3 equals guess an integer, I have to do something like the same thing that we have been doing. We were guessing this. So we have guess 3, we have these things. I have to indent that. And this is guess 3. This is also guess 3. And then I have to do that here. And then put this in. And then we have guess 3 and guess 3. We also have to say this is guess 3. As you can see, this is not amazing, but we're going to clean this up. But I'm going to show you that this will work. All right. So let's run this. We're going to guess a number. We got 40. I'm going to say 78. Lower, we're going to say 9. Great. Look. Oh, I didn't guess lower. But if I do 40, 50, 47, it's correct. Technically, this program's running. It works. Doesn't look great. We're going to clean this up right now. Sorry, this is always the hardest part of this section. Sorry. The last thing I want to introduce today are for loops or loops. And what loops do, I think I have 4 loops here. Yeah, I have 4 loops here. Great. I have while loops and for loops. There's 2 kinds of loops. There's while loops and there's for loops. Basically, this will let you reuse code. I think you just saw me copy and paste a lot of code. That's not the Pythonic way. I always forget which loops I want to use, but let's talk about while loops. We're going to talk about while loops, but I think we're going to do a for loop. A while loop is basically like this, where you'll use while, and as long as this condition is true, you're going to be able to do these actions that are indented in. And so this is like a game. If you were like, if you think about it, like you run any game on your computer, I don't know what people do these days. I don't know. Let's say Minecraft. And I don't know, if I press escape, will it end the program? Basically, it's like, as long as you're running the program, I'm going to do all these things, but here's like an exit to kind of get out of it. That's kind of like the vibe of a while loop. In this case, in this example, we're going to be doing like, we're setting our first variable I equals to 0, and we're saying as long as I is less than n, which is 5, we're going to print I, but we're going to keep incrementing I. So once I is greater than 5, it stops. That's when the loop will stop. In our case, we're probably going to use a for loop. And to use a for loop, it's going to be very similar in that you're going to do a for this variable in a sequence, we're going to be running certain things. So I'm going to open up a new one just to, well, I thought that opened up a new one. It's saved where I was at. We're going to do that same thing. We're going to say I equals 0. And we're going to say for I, sorry, let me go back. Oh, actually, we don't need to do it outside of it. We can, define I inside of the for loop. For I in range 6, we're going to print I. So in a for loop, we are using the keyword for. We're using I as our variable for each thing in our sequence. So for each value in our sequence. So for I in range 6, range of 6 goes from 0 to 6 with not including the end. So as you'll see here, it goes from 0, 1, 2, 3, 4, 5. That's what that does. Yeah, so range will has a stop. It has a little start, stop, step if you really wanted to get more fun with it. And this is part of the Python documentation. You could do nested for loops like we did nested if statements. And I think we might actually get into that. For some more controls on your loops, we have things like break. So if you're doing this thing and you want to stop, you can break out of it. So it'll stop your loop entirely. Or you can continue the next iteration of your loop. Given that, we're going to clean this up. So we wanted to guess 3 times. So in order to do that, what we could have done is we could have done something like this. We could have said for I in range 3, we're going to do the same guess metric stuff. So we're going to say guess equals, and we're going to do input, guess a number between 1 and 100. We're going to put in our first if statement that we did. I'm going to say guess. I'm going to say guess. We're going to do that. And we're going to run this. We're going to say 50. Oh, wow. Whoops. And we're going to clean this up. Oh, yes. We don't need this anymore because we have to do it in our for loop. So run. Okay, so we got 50. We're going to guess lower, higher, and we say 47. We're correct. But if I guessed it in the first place, it says correct, but it's asking me to guess again. So if it's correct in the beginning, I want to use our little break command in our loop. If I guessed it right, I want to say correct. If I want to guess a little first and then go to it, that's correct. So all this code that we wrote down here, we just refactored it. And now we use maybe like 10 lines of code to do the same thing. That's kind of a huge principle for when I'm coding as well, is that sometimes I'll write my original solution, but then I'll go back in and be like, hey, wait, there was a much better way for me to have cleaned that up. And that's this. Great. I think that's what I wanted to get through today. There are more data types than I talked about today. So today I kind of talked about the basic ones, which were like number, string, Booleans, and things like that. As you get into more Python, you'll do things like lists or arrays, which is basically like a grocery list. And then you might even do things such as tables, which are 2D arrays. Or you might do things like dictionaries or things like that. In another version of this workshop, we code Wordle together. I might do that another time. But I think that's a good stopping point for today. How are folks feeling? I know that was a bit. You had to really trust me when I was writing all of that code. I saw the choir over here concerned. And I was like, there's a point. There's a point. Yes, what's your question? Yes.
I use data a lot.
Yes.
So I feel the loop has nothing to do with I. So I is a variable, or I don't quite understand the logic behind it.
Oh, okay, yeah. So basically the way that I'm using a for loop here is basically I want to run this 3 times. And so this is the easiest way for me to write that in. So I'm not using I, and in fact, I might just be able to get by with just using an underscore to help indicate to my developers that, hey, this is a variable that I'm not going to use. So don't care about it. I could use I don't need it though. I could say like, I could use it. I could say like, I could put it in my F string, I'd say like, I'll say I plus 1. And then that could be like a little like, oh, this is my first guess. Oh, this is my second guess. So I could use it like that if I really wanted to. Yeah.
So the for statement is just like we want to do it for how many times?
Yes, that's how I'm using it in this case. If you had like a list of items, then that would be a case where you could iterate through items and use those. Yeah. That's good. Great. All right, I'm happy to answer any more questions. But otherwise, I think we're good to go. So thank you, everyone. Thank you. Thank you. These are all going to be recorded, and next week's is going to be on data wrapper. Oops, I spelled data wrapper wrong. I still spelled data wrapper wrong. Oh, here it is. So next week's DSCoV is going to be on data wrapper. So if you want to get your code in and make some beautiful charts and maps and tables, that will be next week's workshop. All right, take care. And that will be by Max. Yeah, Max will doing. Thank you all. Bye. Thank you. Bye.